Measure phase, process definition, value stream mapping. Flowcharts, process maps, written procedures, and work instructions are tools used for process analysis and documentation. Other lean techniques such as value stream mapping and spaghetti diagrams are also often used. Value stream mapping. A value stream map is created to identify all of the activities involved in a product manufacturing from start to finish. This value stream may include suppliers, production operations, and the end customer. VSMs typically focus on material and information flow. For product development, value stream mapping includes the design flow from product concept to launch. This is the large view, looking at the entire system for improvement opportunities. Benefits of a value stream map include seeing the complete process flow, identifying sources and locations of waste, providing common terminology for process discussions, helping to make decisions about the flow, tying multiple lean concepts and techniques together, providing a blueprint for lean ideas, showing the linkage between the information and the material flows, describing how the process can change, determining effects on various metrics. The value stream mapping process includes define the product family, where we can use a product equipment matrix. A product family is defined as a group of products that pass through similar processing steps and over common equipment. Draw a current state map, which can be done personally. A current state map of the process is developed to facilitate a process analysis. Create a future state map, where we can use creative concepts. A future value stream map is an attempt to make the process lean. Plan for implementation, which can take months or years. The final step in the value stream mapping process is to develop an implementation plan for establishing the future state. Define product family. The recommended value stream approach is to map one product family. A product family is defined as a group of products that pass through similar processing steps and over common equipment. A product and equipment matrix can be used to indicate common features. See the table for an example of the matrix. The matrix shows products that go through a series of common processes. A work cell could be formed to handle a particular flow. Another method is to create a Pareto chart of the various products. The product with the highest volume should be used for the model line. In the table provided in the product family matrix, there are 5 products and there are 4 processes. In this example, the equipment is used in 4 processes. Process 1 uses its equipment for all 5 products. Process 2 uses equipment in Process A and Process D. Process 3 uses equipment in Process A, Process B, and Process E. And finally, Process 4 uses equipment in Process A and Process B. Value Stream Manager. The value stream for a product family may cross department boundaries in the company. This creates the potential for difficulties in coordinating an effective value stream project. Such problems call for the creation of a new position for a value stream manager. This manager must have the authority to make things happen and should report to the plant manager. It is recommended that a production person handle the job of value stream manager. This manager would monitor all aspects of the project. Being a hands-on person, the manager should be on the floor on a regular basis. Current state map. A current state map of the process is developed to facilitate a process analysis. Basic tips on drawing a current state map include: start with a quick orientation of process routes. Personally follow the material and information flows. Map the process with a backward flow, from shipping dock to the beginning. Collect the data personally. Do not trust the engineering standard times. Map the whole stream. Create a pencil drawing of the value stream. Some of the typical process data included are cycle time, CT, changeover time, COT, uptime, UT, number of operators, pack size, working time, that is minus breaks in seconds, WIP, and scrap rate. An analysis of the current status can provide the amount of lead and value-added time. In many situations, teams take on the task of data collection. Both individuals and teams find it beneficial to develop a VSM data box in advance. Value stream mapping definitions worth noting include value-added time, VAT, the amount of time spent transforming the product, which the customer is willing to pay for. Lead time, LT, the time it takes one piece of product to move through all of the processes. Cycle time, or CT, the time it takes a piece to complete an individual process. Future state map. A future value stream map is an attempt to make the process lean. This involves creativity and teamwork by the value stream manager and the lean team to identify creative solutions. Everything the team knows about lean manufacturing principles is used to create the process of the future. Questions to ask when developing a future state map are: what is the required takt time? Do manufactured items move directly to shipping? Are items sent to a finished goods supermarket for customer pull? Is continuous flow processing applicable? Where is the pacemaker process? This process controls the tempo of the value stream. Can the process be leveled? What is the increment of work to be released for Kanban use? What process improvements can be used, i.e. changeover, machine uptime, Kaizen events, SMED, etc.? Implementation planning. The final step in the value stream mapping process is to develop an implementation plan for establishing the future state. This includes a step-by-step plan, measurable goals, and checkpoints to measure progress. A Gantt chart may be used to illustrate the implementation plan. Several factors determine the speed of the plan. These include available resources and funding. The plan could take months or years to complete, and even then, there may be a need to improve upon it in the future. Value stream mapping icons. The following icons may be used with value stream mapping, Kanban, and other lean manufacturing areas. FIFO, first in, first out, Kaizen burst, Kanban withdrawal, Kanban production, electronic flow, Kanban signal, safety buffer stock, supermarket, production control, source, sequenced pull ball, inventory, shipment arrow, shipment truck. Value. Value is defined by the customer. Quite often, manufacturers cannot provide appropriate customer value. In many cases, senior business managers in the United States have lost touch with the customer. They desire customers to purchase products at reasonable prices in order to keep the company profitable. They attempt to increase the performance of the firm while reducing costs. What is value from a German mindset? The German mindset is more product feature and process oriented. The technical people or engineers are in control of the businesses. Thus, the Germans are very strong technically. Therefore, features and enhancements are of utmost importance. However, some of the new, complex enhancements have failed to attract the customer's interests. Often, the German mindset is that the customer is not sophisticated enough to understand the new features. What is value from a Japanese mindset? The Japanese define value in the context of where value is created. As the proportion of the product made on the Japanese homeland increases, the greater the value that is retained at home for their society. Customers in general do not define value based on where it is made. Customers want their needs satisfied quickly. As the yen strengthened, the previous advantages of Japanese companies using Japanese suppliers disappeared. This has resulted in a weakening of many Japanese companies. In the long run, value must be defined by the customer. The customer wants specific products with specific capabilities at specific prices. Specifying value is the first step in lean thinking. New methods must be developed to communicate with customers, to get closer to them, and to find out what they want. Once value is determined, a firm must go back again and again to determine if they really have the right answers. The target cost of the product may be determined after defining customer value. This target cost is more than the market cost of the product. The market cost is typically the manufacturing cost of the product plus the selling expenses and profit. In lean thinking, the target cost is the mixture of the current selling prices by competitors and the examination of and the elimination of muda through lean methods. This analysis results in a target price which is below current selling prices. The firm then applies lean thinking to its processes. Each firm in the value stream is reluctant to disclose too much information to the other firms for fear of price concession requests. A voluntary alliance of the members of the value stream must be developed in order to eliminate the muda hidden in the value stream. The value chain, as described by Porter in 1985, is at a high operating level. A generic value chain involves the key components of human resources, technology, procurement, inbound logistics, operations, outbound logistics, marketing, sales, and service. The discussion and analysis centers on methods to differentiate the firm. However, an organization gains competitive advantage by performing certain strategic activities better or at lower cost than its competitors. The value stream or chain, as used in lean manufacturing efforts, goes into greater detail. It involves a single product stream, which is analyzed for reduction of waste, reduction in cycle time, or improvement in quality. A value stream map is created to identify all of the activities involved in the product. This value stream can include the various suppliers, production activities, and the final customer. The activities are viewed in terms of the following criteria. It adds value as perceived by the customer. It adds no value but is required by the process. It adds no value and can be eliminated. Connor in 2001 identifies the steps for documenting the value stream mapping as product development, identify customer requirements, methods of delivery, and typical quantities. Process design, perform a walkthrough of the process, recording each step. Start from the shipping dock and work back through the process to the receiving dock. Make note of machine times, cycle times, operators, changeover times, WIP, available time, scrap rate, machine reliability, etc. Record the current status on an 11 by 17-inch sheet of paper. Planning, develop a future state map. Value flow. Traditional mass production is often accomplished by the batch technique. The objective is to produce many units of a specific part at a given time in order to maintain the production efficiency of the machines and the overall efficiency of the departments. However, optimization of the individual operation unknowingly leads to sub-optimization of the process as practiced by non-lean companies. The lean effort requires the conversion of a batch process to a continuous flow process. In some cases, converting the batch process to a one-piece flow is ideal. Some of the obstacles to overcome include: the plant has always done it in batches or lots. The plant has a multitude of departments and functions. The plant can't afford quick changeover tooling. The plant has high momentum and inflexible machinery. The plant machinery would be expensive to move. Ideally, in a continuous flow layout, the production steps for single-piece flow without WIP are arranged in a straight line, U-shape, or cellular sequence. Inside this flow, the work of each station and operator must be performed with reliability. When the machinery is performing as expected, there are zero breakdowns. This is the concept of TPM, or total productive maintenance. The quality level of each operation is very high, near perfect, using a variety of defect elimination and detection techniques. The activities needed for production should be in a steady, continuous flow, with no wasted motions, no batches, and no WIP. There should be flexibility to meet the present needs. The work of people, functions, departments, and firms will require adjustments to the value stream to make it flow and to create value for the customer. Instead of creating product in response to an estimated sales forecast, the plant manufactures product as the customer requires it. This is the pull system in action. This results in many positive things for the organization. Cycle times decrease, that is, concept to launch, sales to delivery, etc. Finished inventories are reduced. Work in progress, or WIP, is reduced. The customer stabilizes their ordering. Pricing is stabilized. Most mass production manufacturing firms are in the push production mode. Each operation produces as much as possible and sends it on to the next operation. The goal is to maximize machine efficiency with a maximum amount of in-process inventory sitting around the plant. Contrast the above manufacturing firm with the factory that is dependent on the pull of the market. The receipt of a customer order initiates activities. Each operation produces parts as needed through a signal from downstream. There is a minimal amount of WIP in the process stream. This arrangement enables flow through the plant, using the principles of lean thinking. Quality, machinery downtime, absenteeism, etc. are all of concern. Problems in any area will stop the process, disrupting the pull process. Problems of any sort are magnified and must be immediately corrected. Womack in 1996 suggests that reductions in cycle times, which are due to lean thinking methods, can equal those shown in Table 5.5. Product development, % reduction 50%. Order processing, % reduction 75%. Physical production, % reduction 90%. Perfection. The customer is searching for a value-added product. The pursuit of the first four principles of lean thinking allows the firm to move toward perfection. Solving customer value problems, working the value stream, converting to flow, and making pull occur all help eliminate muda. As the process continues, more muda is eliminated, and perfection seems possible. Perfection is accomplished via product teams working with the customer to find better ways to specify value, enhance flow, and achieve pull. Using collaboration between the value stream partners, that is, suppliers, distributors, customers, and employees, to uncover more value. Using technologies to eliminate muda. Developing new products. Lean thinking principles are the cornerstones to higher performance and economic growth. Perfection is a journey. Some possible improvement results from lean thinking are Improvement area versus reduction or improvement. Labor productivity, 100% increase. Throughput times, 90% reduction. Inventories, 90% reduction. In-house scrap, 50% reduction. Safety injuries, 50% reduction. Product development time, 50% reduction. Capital investment, modest. It may take years to apply lean thinking principles in a company, and even more time to apply lean thinking in the entire value chain. Takt time. Takt time is the available production time divided by the rate of customer demand. In order to understand the measurement of takt time and how it can be improved, a discussion of hypothetical process is presented below. Consider a sequential operation with 5 operators or stations. The times allocated for each station are indicated in Table 5.6. If the takt time for the line is 60 seconds, the immediate observation is that Station 4 exceeds the takt time and will not be able to maintain the pace. One option would be to have some of the time eliminated by moving work to another station. Upon further examination, some thought has to be given to Stations 1, 2, and 5. Do not align with the takt time because of the existing slack time. Only Station 3 has a full 60 seconds of work. A keen Lean Six Sigma specialist will seize this opportunity to review the entire line for another redesign. The total work time used at the current time is 265 seconds. With 5 operators, this equates to 53 seconds on a balanced line. Another perspective indicates that 4 operators will require 66.25 seconds. This is slightly more than the desired takt time of 60 seconds. However, the initial task will be to re-examine the content of the operations by looking at the value-added and non-value-added elements. A thorough study may reveal that a significant portion of time can be eliminated, leading to a reduction of 1 operator and possibly a reduction in floor space. The following 3 cases assume a series of 3 operations, with each processing 1 unit per minute. Case 1. Orders are manufactured in batches of 100 units. Only batches of 100 units are transferred from operation to operation. The total processing time is 201 minutes before the first unit is available. Total order time through the entire process is 300 minutes for 100 units. Case 2. Orders are manufactured in batches of 10 units. Only batches of 10 units are transferred from operation to operation. The total processing time is 21 minutes before the first unit is available. Total order time through the entire process is 30 minutes for 10 units. Case 3. Orders are manufactured in batches of 1 unit. Each unit is transferred from operation to operation. The total processing time is 3 minutes before the first unit is available. Total order time through the entire process is 3 minutes for 1 unit. The above 3 cases illustrates the power of one-piece flow. If a customer changes their requirements, the shop will not have 300 units in queue in partial stages of production. The shop will be able to shift production requirements and provide the first units rapidly. The necessary quality, machine, personnel, materials, and supplier resources must be coordinated and made available as needed. The layout of the line or cell is a starting point. The line should be examined as necessary to improve cycle times, reduce product defects, correct long changeover times, address equipment reliability issues,